Hi everybody, this is Miss Mokanu again, and this is a follow-up video on to the introduction to the periodic table video I made earlier. So just a brief review from there. We saw that on the periodic table we can kind of classify elements as metals, metalloids, and nonmetals. This has to do with their physical chemical properties, which basically tie back to their number of valence electrons. Okay, so before we get more into depth to that, I do want to say off of this slide, you should definitely be able to identify metals. If I ask you, for example, to give me an example of 4 metals, you should be able to identify that on a periodic table that is not color coded like this one. You should also be able to identify some nonmetals as well as metalloids. Okay, and remember, metalloids are these orange kind of staircase shaped formation right here. And then everything to the left of that is metals in blue. Everything to the right of that is nonmetals in green. So let's talk a little bit about more specific groups of the periodic table. Okay, so we're going to see that elements in the same group have the same number of valence electrons. As we know, that is the big idea behind these groups being the vertical columns. That all elements in one group have the same number of valence electrons. And why is that important? Because that gives us an idea to the reactivity of these elements. Okay, so let's start off with the first group, which is the alkali metals, which are highlighted right here. So at the very left of the periodic table, these are alkali metals. They are a very, very reactive group of metals. This group is group number 1, meaning that all these metals have one valence electron. And what makes them very reactive is that they basically want to give away that valence electron so as to be able to have a full octet. They want to have, as every other atom on the periodic table wants to have a full octet, meaning 8 valence electrons in their outermost energy level. And the easiest way for the alkali metals to achieve that is to give away their one valence electron. So they really want to give away that one valence electron, which makes them very reactive. They're soft and silvery colored, and their reactivity increases as we go down. So lithium is reactive, sodium is more reactive, potassium is even more reactive, and as we get down, they become more and more and more reactive, whereas cesium and francium being the most reactive, are extremely reactive. Moving on to group number 2 now. So group number 2 is the alkaline earth metals, as you can see here, highlighted in red on the periodic table. Because these elements are all in group 2, they all have 2 valence electrons. All right, they are fairly reactive. They are not as reactive as the alkali metals, but they are still fairly reactive, meaning that they are willing to give away those 2 valence electrons in order to achieve their octet. And if you are not sure what that means, remember to go back to this slide example right here where we looked at sodium, and we saw how sodium, being an alkali metal, had 1 electron in 1 valence electron, meaning 1 electron in this outer energy level. And it really wants to give that away, as shown here. It wants to give it away because when it gives it away, then sodium is left with its full octet on the second energy level. All right. So that's always the idea behind all of these groups, is how reactive they are is based on how many valence electrons they have, which means how much do they want to hold on to them or give them away, basically to complete their octet. All right, so alkaline earth metals, they are metals as the name indicates, and many of them are found in rocks in the Earth's crust. Moving on the periodic table to the right, we're now getting into the transition metals. As all metals, most of these are good conductors of electricity. They are malleable, meaning easily bent or hammered into wires or sheet. And as all metals are also ductile, meaning that we can easily draw them into wires. So these are just little facts about these different groups of elements that you should be familiar with. Some pictures of the metals we've been talking about. Let's move on to metalloids. So metalloids are basically this orange group of elements over here that is in the shape of a staircase. They, as you can see, are in between the metals, which are in blue, and the non-metals, which are in green, and they share properties of both metals and non-metals. For example, as far as being conductors of heat and electricity, how conductive they are depends on the temperature they're at. Okay, so they're called semiconductors. Silicon and germanium are two very good examples of that right here on the periodic table. Their conductivity, they tend to become better conductors as their temperature increases. And here are some examples of these semiconductors. What are they used in? In a lot of circuit boards, as you see here, a lot of computer technology. Finally, getting into the non-metals, which is the group of elements right here. And these are broken down further into other groups, and we'll talk about them in a minute. But getting down to this non-metal region, these, as you can see, are located to the right of the metalloids, to the right of the staircase. They are not good conductors of electricity and heat. And why is that? Well, that is because they, as you can see from their periodic table location over here, they tend to have more valence electrons than these elements over here. We got group 1 and 2 with 1 and 2 valence electrons. Then over here, we got group 6, 7, 8. So they end up having more valence electrons, meaning that they want to hold on to them. They don't want to give them away. And because of that fact is what makes them basically not be good conductors of heat and electricity. Let's look a little bit more in detail into this region here of nonmetals. So one important group of nonmetals is the halogens. The halogens are right here in group 7. They are very reactive. They have 7 valence electrons, just like this example that we went over in the last video with chlorine. Chlorine is one of the halogens. You can see if you draw its Bohr model, on its outermost energy level, it has 7 valence electrons, meaning that it really, really wants to get one more electron from another atom to complete its octet. And because it wants to get that electron so badly, it's so close to completing that octet, basically that's what makes it so reactive. And most of these elements are also poisonous. All right, noble gases, our final group right here to the very right of the periodic table. These, if you draw their Bohr model, you will see that other than helium, they all have 8 valence electrons. They because they have completed their octet, they're happy with those 8 valence electrons. They don't want to interact. They don't need to interact with any other elements, which makes them very unreactive. Okay, they just do not react. Helium is an exception in that it only needs 2 electrons in its outermost energy level to be happy, but it also shares a lot of properties with the rest of the noble gases. All right, so I think that's all I wanted to say. Please Make sure basically you are familiar with this activity in class where we divided metals in red, non-metals in yellow, and metalloids in blue over here. And then you definitely need to be familiar with these groups that are outlined here. So the first group, alkali metals. Second group outlined in green over here is the alkaline earth metals. We got transition metals right here outlined in red. And we have the halogens, which are outlined in orange. And we have the noble gases, which are outlined in blue, as you can see. So you need to be familiar with all of these elements. You need to know, what kind of reactivity do they want? How are they highly reactive? Are they not that reactive? Are they good conductors or poor conductors of electricity? You also should know as you go across the periodic table. So as we go from left to right, for instance, let's look at this fourth period here that starts with potassium. What happens to the metallic character of the elements? Do they tend to be less metallic, more metallic? What happens to that? And if you look at your color-coded periodic table, you will see that as you move from left to right, elements tend to become less metallic. So over here to the left, they're metallic. Then we get into the metalloids, which are kind of in between metals and nonmetals. And then you finally get into this region here of the nonmetals. So elements tend to get less metallic as you move across the periodic table from left to right. Let me see what else that I can give you guys some hints as far as what you need to know. Obviously, you need to know what makes the difference between periods. What periods relate to what? And the answer to that would be that periods relate to the number of energy levels that an atom will have versus groups, which relate to the number of valence electrons. So that is very, very important concept, very fundamental concept behind this periodic table. All right, I will see you guys in class, and I hope this tutorial was useful for you.